Hello everyone, this is Jens and Elliot out of CREE's remote office in beautiful Vancouver, BC, as well as Rainer and Saranch, who are joined in from Austria. We will be the hosts for today's webinar session, so thank you for joining us today. And this is a really exciting moment for us because we're hosting our first webinar. Let me briefly introduce myself. My background is in architecture. So before joining the CREE team in Austria in 2014, I have worked in collaborative design environments in Europe as well as in North America, mostly on healthcare, transportation, education projects. So what I'm passionate about is using the virtual design and construction as a tool to minimize the ecological impacts of our built environment. And over time, I have been developing BIM standards and processes, as well as integrating a range of computer technologies into the design process. And thereby, I feel fortunate that I can pass on some of my discoveries to my students here in Vancouver at the British Columbia Institute of Technology's Building Science program. But so first and foremost, let's do some housekeeping for the webinar. Just wondering if the audio is working okay for everybody. Can you hear me? Is there any echo? I'm getting thumbs up from my coworker Elliot, so there seems to be no complaints about that. So I have quite some material to cover for you. I'm looking to go through slides of section 1 to 5 for about 45 minutes, during which I would like to give you an overview of lessons learned during now almost 10 years that the CREE team has grappled with mass timber construction methods. Please ask questions at any point during the webinar by using the chat feature in the software. There should be like a little, I think my computer is a little gray bar that you can pop open that you can use to ask questions. And we will collect those questions and try to answer them at the end of the webinar. So if your questions will not be answered during this broadcast, don't worry. We will put together a Q&A document that we will distribute to all of you after the webinar. So that there's a section 7 in the document that I will not show during the presentation. It contains additional resources for you to check out after the webinar. This will be web links and suggested readings and so forth. And be aware that some of the resource section contain are like clickable hyperlinks with further information. So this presentation will be made available through the GoToWebinar software during the session, but also we will send out an email that contains a download link after this session today. So let's get started with looking at some of the megatrends and challenges for us working in the construction sector today. Population growth and urbanization is a major trend that affects how we build buildings and how we organize our cities. While in 1800, about 25% of the population lived in cities, the proportion of city dwellers in 2008 was 50% for the first time in the history of mankind. So by the year 2050, it's forecast that more than 75% of the people worldwide will live in so-called megacities, meaning in cities with more than 1 million residents. So even though the urban centers currently occupy less than 5% of the world's landmass, nevertheless, they account for around 70% of global energy consumption and greenhouse gas emissions. Innovation in urban infrastructure and technology is essential when addressing the urgent issue of housing this new urban population. Every building today is basically a new invention. It's a prototype. Yes, it makes sense from the architectural point of view that the building reacts to unique site conditions, to the climate, and to unique programmatic requirements, but it does not make sense in regards to the guts of the building. So a lot of waste in the process sense is produced by this chaotic and siloed approach, like repeating the same tasks overproduction of components, and elements, scheduling issues like waiting, change order requests to level of detail issues in the documentation. So let's try to get rid of this. Coming to waste more in the physical sense, these are numbers that you have come across before, I think. Nevertheless, we should repeat them over to internalize. So today, our industry worldwide is responsible for around 40% of resource and energy consumption. In addition, it creates 40% of today's waste that goes to the landfills or the incinerators. This makes it very clear that there's an urgent need for action in our industry. Let's have a look at a bigger picture. Each kilogram of industrial products is responsible for an average of 30 kilograms of nature. This is not only the stuff and the waste that goes into the product itself, but also the energy that is used to transform natural ingredients to technical materials. To relate this to resource consumption, or to relate this resource consumption to the environmental impacts that you might be more familiar with. So just around 150 years ago, we as humans have been able to increase our ability to extract energy from the environment beyond the intake of food and the use of fire. So in context of human history, the discovery of coal, gas, and oil seems like the blink of an eye. So those fascinating fuels store billions of years of solar energy in a very dense and portable form. Just imagine yourself pushing a car 15 kilometers along the road, uphill and down. This is the service of 1 liter of gasoline to us. So very soon we'll have used up all economically viable reserves. Let's try to keep this valuable stuff for the common good and emergency services in the future. And let's build our buildings with renewable resources. As one of my favorite writers on resource issues, Richard Heinberg, puts it, the party is over. Yeah, so this diagram before suggested that the energy is the devil, and it is in a way, but we have to look beyond the obvious, we believe. So as building design is moving towards high performance in regards to envelope and operational energy, like passive house or net zero, the embodied energy suddenly makes up 50% of the overall impact or even more. And when you look at those emissions over time, you see that those first 50% of those carbon emissions are being released at day one or even before you build. And the second half then comes over time, over the building life of 50 or 60 years, depending on the definition of where you live. And you might even hope during that time for more efficient energy generation technologies to be developed. So the one-sided discussion on energy and greenhouse gases, though, distorts our view of urgently needed radical reduction of consumption of raw materials. And it is the material consumption levels that presuppose the use of fossil fuels with its known, with its known impacts. To achieve the same kind of service levels and comfort of the current high consumption economy for a low extraction future, we need to dematerialize our economic processes in a controlled manner. Metrics and action plans have actually been introduced and developed during the last 25 years by an international science community around the world. Well-known scientists like Amory Lovins, Richard Heinberg, Friedrich Schmidt-Blake, and others clearly show a path on how we can redesign industrial production and improve resource productivity 4, 5, or even 10-fold. Every material, product, or service can only be provided by interfering with the ecosphere. So let's take a computer, for instance. For producing this product, you need material from nature and you need energy. Many different materials from many different countries have to be mobilized in nature, extracted, processed, transported, and finally turned into thousands of different components needed for the computer. Equally, in order to make energy available, you have to invest materials like steel, copper, oil, and sand, and even for harvesting solar radiation. So at each step from the cradle of nature to the final product, waste is created. And that's what we call the ecological rucksack. And the same concept applies to our building materials as well. So resource productivity and dematerialization is the perspective that we're using and implementing in regards to building design. Our building design decisions are driven by looking at optimizing the resource performance throughout the building life cycle. So unfortunately, we're living in an era in which the existing systems are reaching their limits. So endless growth cannot persist in a finite ecosphere. It is actually those natural systems that support our basic human needs and life on this planet that we enjoy so much, like the clean air, the protecting atmosphere, nutrient cycles for food production, water systems, and biodiversity are being altered dramatically by this accelerated resource use nowadays. So being the master of glass, steel, and light, the materials at his time, visionary architect and designer Richard Buckminster Fuller is often cited with the sentence, "How much does your building weigh?" So this is exactly the question that we're trying to answer during building design. The ecological rucksack is a simplified proxy method to assess the impacts of products and services over the whole life cycle, from resource extraction to the end of life. And there are also other more detailed methods available, like life cycle assessment, and we'll talk about those later and learn about implementation in an upcoming webinar. Yeah, so we don't have two planets, so let's plan for the one. And we were trying to do this when we launched the Lifecycle Tower idea. So photovoltaics is great, but we think we can do better than that. So carbon is a key component of all known life on Earth. And climate change is the result of breakdowns of existing carbon cycles that were basically existing for thousands of years in a balanced manner. And these breakdowns are caused by us, so it's a design failure. Greenhouse gases extracted from their underground storage and put into the atmosphere make airborne carbon a material in the wrong place at the wrong dose and the wrong duration. Wood is a renewable resource that grows from the sun and from the available fugitive carbon. It is the ultimate solar product. Trees absorb carbon while providing oxygen. Our modern timber-based products are stable, will not shrink and twist, and can be pre-cut and prefabricated to exact tolerances, and are available worldwide and will last a building life or even longer. So we look at wood from the perspective of avoiding carbon emissions from other forms of construction, but as well as from the point of view of potential carbon sink. We use visible wood in the support structures as much as we can. We just don't want to encapsulate it for obvious reasons. So reconnecting human beings with natural systems has all kinds of positive effects on their life. For example, these are just some bullet points from the research during the last 2 decades. There's lower blood pressure, lower heart rate, faster recovery from illness, lower pain perception, better creative task performance, better concentration task performance, and so forth. But I personally think that we are in dire need for connecting to natural systems that go beyond the effect of worker performance and accelerated healing times. I think we need to do this to appreciate and value those systems that support our lifestyle. There is more literature on this topic, on the topic of biophilia, in the resource section as well, when the handout will be available. So with the accelerated demand for tall wood structures, the legislative bodies will be put on the spot to increase legal certainty through evolving building codes. Some countries, states, and municipalities are now moving into standardizing the codes for taller mass timber structures. Today, still in most jurisdictions, all buildings over 6 stories will have to be legally built with concrete and steel. Meeting certain provisions and proving equivalency you can build with mass timber nevertheless. We have demonstrated with our build projects and are currently pushing the boundaries and showcase that we can build tall with wood in an urban context. Mass timber has not and probably will not reach any limits in possible height soon. So the tallest mass timber proposal that I've heard of so far is an 80-story tower in London, England. So these super tall projects do not really represent a fair share of the market yet, but they attract a lot of media attention, which is a good thing for that those projects will drive innovation in technology and help develop a level of confidence. If we really want to make a difference, we want to tackle buildings between 4 to 10 stories, as they make up the bulk of new urban construction. As well, it is this building height that offers a sweet spot in density for various reasons, from potential energy independence, transportation effectiveness, sense of community, access to nature, as well as comfort and resilience. So I'm going to read to you 3 numbers that are trying to answer the question on the slide, and let's take those numbers with a grain of salt. I have not calculated those myself. So the number 1 statement is the amount of wood used as the main building material for a 30-story Lifecycle tower regrows in the United States forest within 3.5 minutes. Second would be the wood used for the IZN building that uses the CREE system regrows within 1 hour in the Austrian forests. And 1/3 of the current forest regrowth in Germany would be sufficient if all new construction in that country would be built with wood. So let's not use wood as fuel, let's have it go through a durable phase, or as many durable phases before. The use of wood for buildings in ever larger volumes needs to go along with a responsible management of our forests worldwide. There is a lot of potential for reforestation in areas that have been harvested and transformed during the last 500 years. So from my European perspective, the Mediterranean comes to my mind. Centuries of deforestation have turned Spain's lush forests into barren scrublands, making them vulnerable to erosion. The same applies to many other areas in the world, especially tropical forests are of concern. So wood is the best material available to us, but we still want to be very mindful in its use. So as a first step in the founding of CREE, the technical feasibility of buildings in timber construction was investigated as part of the so-called A+ research project, and this project began almost 10 years ago in 2007. However, this did not take into account the commercial marketability of the developed concepts or its chances of obtaining approval under construction law. Following on that first step, our cooperative and multidisciplinary research project called the Lifecycle Tower Project was initiated under the lead management of Romberg Construction. It was basically proven on paper that you can build 100 meters tall with wood. So 10 years later, we not only have written results, but also the proof. We will see project examples in a moment. So CREE is rooted in the region's tradition of building craft and local materials. The company CREE that I'm representing today is a startup spin-off from Romberg Construction and is based on the Lifecycle Tower Research Project. And CREE stands for creative resource and energy efficiency. Hubert Romberg is the driving force behind CREE. Hubert serves as the managing director of Romberg Holding and Romberg Sursa Rail Group. So as a fourth-generation family-owned company, Romberg Construction is obviously especially concerned about innovation and long-term planning. He wants to make a difference in his segment. So let's move on to the core idea of the Lifecycle Tower. We're basically looking at a simple skeleton structural system that consists of glulam columns and timber concrete hybrid slabs. We have looked at and executed various alternatives for how we can coordinate hybrid floor slabs, the column spacing, and the edge beam situation. Depending on which subsystem we choose, the column spacing can be larger than the indicated 3 meters, and the slab width is driven by the width of the truck that your local authorities will permit without costly police convoy driving, which is typically around 3 meters, might be a little bit more depending on where your project is located. The length is not so dependent on transportation. It is more the depth of the structure, which is driven by the economy of your project. So the previous structural skeleton diagram you just saw was developed with asking the same question that was posed before by Bucky Fuller. We're basically minimizing material resource, no matter if it's the concrete or if it's the wood. We only want to use it where it's actually absolutely necessary. So, for example, the prefab concrete top is only between 80 millimeters to 100 millimeters thick, compared to around, let's say, 300 to 350 millimeters for similar spans with cast-in-place concrete skeletons. So through that, we reduced the carbon from less concrete and the sequestered sequestration in the wood by 80% for the structural system. The concrete creates the non-combustible layer separating the individual stories. Together with the glue lamp beams, composite action is created. How wood and concrete is connected, we see in a moment. All columns in this instance occur in pairs at the junctions between the modules in the facade plane, each one bearing one floor element. And the space between the beams provides space for services. Chilled beams provide radiant heating and cooling, and other equipment like lighting, ventilation, smoke detectors, potential sprinkler system is also arranged in the void between the beams. So with the next couple of slides, I would like to summarize some of the core aspects taken into consideration when the Lifecycle tower system was thought up. The system components are tended to be resourced and manufactured as local as possible. Studies show that the wealthiest economies are precisely those with the highest percentage of locally owned businesses. We had heard that before, why lifecycle thinking and systems thinking is so important to us. And in a well-attuned process, communication failures between architects, designers, contractors, and procurement teams compromise the successful outcome even more. We're convinced that our aspired outcome will work only if we leave our silos and work collaboratively together from day one. So with the next slide, I would just like to summarize some of the main advantages of hybrid timber. Prefabrication. Wood components are used in increasingly large prefabricated elements and allow for short construction time, dry and clean building sites in the city, as well as a fraction of the noise that is made on conventional construction sites. Additionally, the moderate weight has a positive impact on transport costs as well as on foundation. Yeah, so this is just kind of bragging about the operational building performance that we had achieved with our various built lighthouse projects. Mostly it's the LCT1 tower and the IZM building, both of them in Austria. So the LCT1 was certified LEED Platinum. Both buildings went through the European rating system, DGNB, and were also both certified Platinum through that rating system as well, both of those. And I think another project or another 2 projects are actually certified Passive House projects as well. So considering different seismic zones. We had collaborated with Arab engineers in the San Francisco office to revisit and adapt the LCT system ideas and approach for high seismic zones as well. So what about fire protection? So for the construction of the LCT-1 building in Austria, several prototype floor modules had been taken to a large fire testing laboratory in the Czech Republic. And so this is a look into the oven at 1000 Celsius. You see the glue lamp beams to the right, kind of charring away. And after they came out, we received a certification according to Eurocode of fire resistance of REI or R90 for the timber concrete hybrid slab. So this was an important condition of the local fire protection authorities in Austria and a crucial step towards realization. Austria has a long history of prefabricating high-performance building components out of wood. The process begins with software used to cut lumber using CNC machinery. The members are assembled in a carpentry shop under controlled environment where windows, insulation, sheeting, vapor retarders, and finishes are already installed. The components are made to tight tolerances and can be quickly assembled on-site and meet the most stringent air tightness requirements, which is an important precondition for operational energy performance. Just think of the passive house requirements for air tightness. So moving from the wall panels to the floor panels, so you see the glue lamp beams before they go into the formwork for the concrete. You see the notches in the glue lamp beams. They're used to create the composite action between the wood and the concrete for most of our buildings. So when the concrete will be poured into this prepared formwork, it will flow into the cavities in the beams and interlock with the glue lamps. So these are just three of the slab panels flat packed and ready to go to the site. And with that, we move to the site to go to the assembly. After, in the instance of the LCT-1 building, the combined facade with the structural column element is being installed in this picture. And then the hybrid slab is craned in. And you notice the 4 holes at the corners in the concrete edge beams. And it is threaded via the holes in the edge beams onto the pins in the column that you see in the background. So this steel component will make sure that there are minimal tolerances in height, even for a tall building. It's like the tolerances are just a couple of millimeters, even if you go 10 stories high. So after the central core had been erected using traditional cast-in-place concrete, the CREE team started with the assembly of the prefab superstructure. I will show a little hand-animated sequence, so each slide represents one day of the assembly process. So it was actually really hard for the scaffolding contractor to keep up with the erection. So basically there was one story finished per day and covered during the night in case there are in case of potential rain events. So the scaffolding was actually needed for the aluminum facade that was to be installed later on. We could also imagine components that have the rain screen installed in the factory. So that's day 7, and then on day 8, the show effect, winter was coming back. So from the construction sequence of the LCT-1, let's move into a little project portfolio section. What you will find in the project section is that even though we reduce production variability with components and standardized or work processes, the end product is always as unique as its site conditions and project goals. So this 8-story lighthouse project is intended mainly for use as an office building. It was perceived by Romberg Construction as the client to prove the case of all the research work done. The top escape level is at 21.95 meters, so it's just 5 centimeters below the high-rise definition in Austria. Just to give you some parameters beyond the innovative structural system, the building has triple pane windows as a photovoltaic installation on the roof. The up to 40 centimeters of insulation are due to the fact that this building is a passive house in a mountainous climate zone. District heating with thermal power station that is operated with wood chips. LED technology throughout, which was new at the time, or newer at the time. Sensor control, lighting and glare protection, heat recovery, ventilation as well due to the passive house requirements. So back to the assembly phase for a moment. This is the wettest state during construction. So no curing of concrete, no drying of materials from rain events, ready for interior fit out. That's the same space a couple of days or maybe a couple of weeks later. I wasn't personally there during construction. Same space again. So this is a typical office, open office situation in the building, in the LCT1 building. So in addition to its main office use, the Lifecycle Hub on level 1 and 2 is open to visitors as a showroom for sustainable building solutions. So with that, let's move to the second major project, which was the first commercial application of the Lifecycle Tower system, despite the fact that it's not a tower. So the building serves as a workplace for administration and engineering services for the local hydroelectric power utility Illwerke in the Montafon Valley in Western Austria. The project was initiated through a design competition which was won by Hermann Kaufmann Architects in 2010. Local timber from the western provinces of Austria was used almost exclusively for the structure. The oak wood for interior fitting and exterior cladding was sourced from deciduous forest just across the border in the south of Germany. The building was built with around 1/3 of its length reaching out into the lake. So sheet piling was used during construction for that purpose. The IZM primary energy consumption is under 30 kilowatt hours per square meter per year. So this is even for passive houses, it's really low. And that's like the heating demand, which is under 15 kilowatt hours due to passive house, is completely recovered by a waste heat system from the local power plant, and a heat pump system covers the cooling demand. The wood elements of structure and construction are left visible within the building, so no drywall linings was needed. Glue-lamp double columns on the outside, as well as fire-resistant concrete-filled steel tube columns in the middle grid, carry the load of the LCT timber concrete hybrid slab elements. A strict facade grid pattern glazed above desk height lends the building transparency and spaciousness. The projecting roofs act as protection from both weather and glare. In situ, reinforced concrete construction was carried out on-site up to the ceiling level of the ground floor and for the 2 access towers. After the concrete work, it took 6 weeks to assemble the shell, or core and shell, to assemble the shell of the building, including the facades using the LCT system. The building services are integrated within the structural rhythms. And the building has been certified by Passive House Institute, as well as achieved platinum level with the European Green Building Rating System, DGNB. Energy and carbon studies were undertaken comparing different design alternatives. And those studies demonstrated that the IZM was built, as built, has only 46% of the carbon footprint compared to an equivalent building with a conventional structure. So the next building that we see here was actually an existing one-story production facility that was expanded vertically. And the 100-millimeter prefab concrete slab elements were cast in the factory, and you see the capillary tube system in the concrete that provides the capacity for heating and cooling. And so this was a different approach in this instance. A timber connector system was used for dry connection of the prefab concrete slab with the glulam beam on site. So full thread screws develop composite action and give this hybrid structure a high strength weight ratio. So another benefit of this connection type is that the edge beam can be made in timber as well. Thus, the column position is not dependent on the slab width, which is driven by road transportation. So heating and cooling was achieved with the activated concrete slab, so no mechanical equipment in this instance was needed between the beams. So this is the project that I did get my hands on experience with design and rationalization and documentation. A rather small project, but experiencing the building assembly when you are on site, these 8 by 3 meter slab panels are just huge when they fly over you and are being craned into the construction site. So this was the first mixed-use typology in the Lifecycle tower system. So it contains commercial space and office on the bottom 2 floors and residential on the top floor. This is just a peek view into the office space of the main tenant. So moving on to on the boards. So the Eckwerk in Berlin, Germany, will be an innovative research and production hub for the vanguard of the next generation of IT companies. A place where long-term and sustainable business models are developed and implemented. You see the connecting walkways called the experience path that weaves through the project site and promotes encounters between occupants. So after receiving a design proposal from the client's architects, the CREE team, together with the design architects, rationalized the design, which was thereafter called the Eckwerk 4.0. So after extensive review and streamlining of various design categories from fire protection to heating and cooling, ventilation, structural spans, and method of construction, while keeping the design intent. So this is actually a rendering of the version 4.0. So while keeping the design intent, the price estimate for the project could be reduced dramatically. The expansion of the existing Romberg headquarters in Bregenz, Austria, will be a platform for implementing and testing of IoT concepts based on sensors and control systems to further optimize the service that a built space can provide to the users. This project is in early concept development. This is a very recent proposal by Kleihues and Kleihues Architects for affordable high-rise living in Berlin. This tower is designed as a modular building system, providing many possibilities for adaptation based on different urban situations. And this project showcases the adoption of the LLCT system for residential. For the first time, this was a public-private partnership submission for the ETH University campus in Zurich with Fink and Jocker architects from Munich. Just gonna skip over this one. So last but not least, some timber projects that come out of the Romberg group and showcase the expertise in prefabricated timber construction beyond what CREE has developed so far. The CREE team collaborates constantly with those subsidiaries. And so we mutually benefit from the expertise and exchange between those specialized internal groups, especially in regards to the bandwidth of available engineered timber products and their application. So I want to show you just one more concept that actually demonstrates strategies that we use to rationalize a rather unconventional shape for prefabrication. So also these kind of footprints are possible. So in the context of Just Seeing project portfolio, I would like to announce that the production of CREE hybrid slabs has recently started in Singapore. In the beginning of 2016, CREE had decided to license the intellectual property rights and know-how to general contractors outside of the German-speaking countries. Singapore was the first country to acquire a license. In Singapore, a school building for the Noya Junior College is to be built using our Lifecycle tower construction system. A 10-story and a 12-story building will be completed on the college campus by 2019. So this year, CREE has also entered a license agreement in Denmark, as well as in the United States. On the east coast of the United States, we're working with an established modular construction company that was focusing on steel so far, called Full Stack Modular. CREE will also expand to Luxembourg, Belgium, Norway, and Sweden in 2018. So how do we make high-performance prefab work for us? So however you want to call it, like digitalization, Industry 4.0, Building 4.0, virtual design and construction, or just building information modeling. It's kind of almost all of them the same thing to me. So used and implemented right, these tools and processes are really conducive for the ambitious designer that wants to connect tectonics and beauty with metrics and performance intuitively. Don't fear due diligence to achieve resource and carbon performance goals. You can focus on the things that you love to do and collect the necessary metrics as you move along the project. The digital twin throughout the building life, from concept through occupancy to building reuse and to urban mining even, that is our vision. So we developed a digital implementation strategy, and it is a moving target as our perspectives change with experience and every new project, and also technology is developing fast. But basically, the the arrow in the middle kind of represents the continuous stream of model data development and coordination throughout the project lifecycle. And these little puzzle pieces are actual use cases that we want to use the continuous data for that are geared towards specific phases during the lifecycle. So the darker the color of these little puzzle pieces, the more developed those use cases are actually internally for us at CREE. So yeah, if you really get into the nitty-gritty of implementing building information modeling, there's just a huge ecosystem out there that is available that cater to different kind of aspects of building information modeling. And you basically, you have to research, try, pick, choose, and then run with it until you kind of hit the wall and choose something else. So, those are only tools, and we think the tools need to be aligned with a changing process. Only then we really want to call it BIM or Building 4.0. So our collaboration versus silo was one that we had already mentioned. So this depicts our strategy depending on the team's maturity in regards to expertise and technology. So depending on how confident you feel in regards to the use of BIM tools and coordination tools, we suggest a certain depth of implementation. So if our BIM level 3 scenario, in our BIM level 3 scenario, all stakeholders, they want to feed their current project knowledge in real time into a central repository. And this diagram also indicates some of the choices we had made in regards to software. So using the selected set of tools, we have also developed a collaboration and data exchange protocol that can be used no matter where projects are located. I'd just like to mention at this point that all this technology is not replacing face-to-face communication between the stakeholders. It is just a tool that helps out. So we're looking at client expectations as well as internal process optimization to move towards lean design and construction processes. So you probably all have seen the same diagram, which is based on the kind of the famous Patrick McLeany diagram. But I would like to stress that in prefab, with its interwoven supply chain and fast-track schedules, the flow of early and accurate design information is even more important than in conventional design build processes. So the earlier in the project that decisions regarding offsite modular can be made, the more positive the impact will be in regards to risk, cost, quality, and schedule, and so forth. So from the ego to the Lego principle, so this was a tagline in Hubert's recently published book, and we took this somewhat serious and created the kit of parts of parametric rule-based components that make up the LCT system. And yeah, there have been many generations of those components or families being developed. And we prepared documentation on how to use these parametric components and how they relate to each other. So we had to be able to name and sort our building blocks, and therefore we created our own classification, as prefab and hybrid has not really been captured so far by available classification systems. And then we started sharing a conceptual variant via the BIM Object Cloud service. And we use the same platform internally with our partners to distribute more detailed content depending on the country. Preferred and tested suppliers then can be added to the recipe. So design integrated lifecycle assessment is another concern to us, as we would love to base our design decisions on instant feedback of environmental impact. And so we have used and tried different approaches for implementing this as a design decision-making feedback loop during design, as well as a rating system compliance tool for LEED, DGNB, or Living Building Challenge. So we built dashboards inside our BIM data hub, Revit in this instance, using schedules to calculate building weight, material input per net usable floor area, and CO2 equivalent. We used simple scripting to connect to mainstream Excel, as well use purpose-built software plugins where it made sense. So LCA is simple math, but to integrate it into the rather unpredictable architectural design process is another challenge. So this is a project that is close to my heart, and I'm rather excited when I can tell you more about it at a deep dive follow-up webinar in spring 2018. And finally, we packaged our perspective on virtual design and construction to help us all to work effortless as a team towards our vision of providing zero impact buildings. So we're now almost at the end of our first webinar. How am I doing with time? Yeah, so we've got kind of around 10 minutes left. So we hope that we have planted some seeds and made you curious for more. We would like to invite you to walk the talk together and be part of our community. So we have 5 more webinar modules planned, and we will go over, I will go over the topics shortly before we then want to answer some of your questions. So the 5 follow-up webinars will bring you up to speed to conceptualize and deliver an LCT system-based mass timber design. So these 5 sessions will give you the competence and confidence to deliver and advocate mass timber based on the Lifecycle Tower principles. You will be invited to a design competition also that will happen in the fall of 2018. All participants will be published through the CREE website and social media. So this first webinar was provided to you free of charge. The following 5 modules will come with a small investment on your end of 50 euros for each of those 5 modules. So after today's webinar, you will receive an invitation email for you to register. So just a brief overview of what we have planned for the following sections. Each slide represents one upcoming webinar session. So the first one basically goes over all the Lego pieces that you need to know about. So rules and constraints that you want to adhere, and also where you could deviate. So don't fear, it's a lot of fun with purpose. So in the third webinar, we will talk a lot about implementing software, processes and standards, and also have a closer look at some case studies and look at quality control for manufacturing processes, as well as the fire safety compliance path that we choose for our projects. In the webinar number 4, this will be looking at kind of design elements that are not part of the core system. So looking, or not part of the LCT system per se. So we'll look at options for central cores, in situ concrete, prefab, or timber. Balconies, we'll look at balconies, lodgers, staggered levels, integration of building systems, partition walls, best practices, and so forth. The webinar number 5 is the LCA deep dive session that I had talked about before. So we look at software and BIM integration, methodologies and standards, best practices for different phases of design, and which databases make sense for which country. And we look also at compliance modeling for different rating systems. And the last planned webinar, number 6, will look at building performance, and mostly at building envelope performance, thermal performance. A lot of it will be related to passive house at the LCT1 and at the IZM. We'll also look at several sound protection issues and how we solve them, as well as fire testing and certificates as well. So thank you, and I will move into the Q&A section of the webinar. I'd like to introduce Rainer. He's the technical director at CREE, and he will help me to answer some of your questions. Rainer, can you unmute yourself?
Hello, yes.
Hi, Rainer.
Hi. Yeah, hello to the audience. Thank you very much for listening. I'm trying to go through some of your questions now. And there's plenty of them. And I'm trying to sort out and to cluster them a little. So let me start with some questions regarding durability of the timber construction. So there's one question: can insects and termites harm the CREE structure? This might be related to one of the slides that we have been showing according to our project in Singapore. Because of course in that environment humidity and insects are an issue. However, insects themselves or fungi are not a problem for industrialized wood that we need that we use, that because this kind of engineered wood is kiln dried and it has a certain very low equilibrium humidity. So fungi and insects just won't attack it as long as these components stay within the built environment or in the envelope of the building. And that's what we usually do. In Singapore and other parts of the world, we have issues with termites, of course. Termites are very aggressive and they don't care about the moisture content of the wood, so they even attack dry wood. That's why in most of these countries they have some plans against termites, which also apply to standard buildings because there's furniture involved or something like that. So in these maintenance plans also apply to our buildings. We do have to treat them with anti-termite chemicals, which are not harmful, but it's just a way how to do this. But the most important thing to mention here is that the structural components of our buildings are not covered or not clad or not added by any additional layers. So you can always check them and you will notice if something goes wrong and if you might have a termite infestation, which never occurred to us up to now. Another question regarding durability is what happens in case of water pipe damage or sprinkler release. Of course, things like that can happen. Nobody can entirely avoid them. First of all, the concrete slab that is incorporated with our system gives first and very good protection from floor to floor. And the second, I can repeat this again because it's the same like the answer before. We do not cover the wood, and so every water damage can be detected. You will always know where the water goes because you can see it, and then it can also dry out, so there is no issue with that. So that's something that you need to know about durability. Okay, let's see what else we have here. So there's one question regarding the wood species. It just came in. Yeah, the wood species is just the standard species that you use for the manufacturing of glue laminated timber or cross laminated timber. In our countries here in Europe, it's mostly spruce, but it's also fir and like softwood that you can also have everywhere in the world. And so that means we do not need special species of wood. We use the most available ones that is provided by the engineered timber industry. Okay, so let me go through the list. So there was one question regarding the freedom of design. Of course, if you're talking about systemized design, and you, Jens, as an architect, might have these questions sometimes as well. So, of course, you have to stick with certain rules of the grid layout. But as you have seen in one of the slides before, we also are able to lay a systemized design behind even round buildings. So curved buildings, even those can be covered by a systemized design. And the second is, of course, we you have a lot of freedom in the creation of your exterior wall, of your facade, because we have non-load bearing exterior walls. We just have the columns, and so there is a certain freedom in giving the architectural expression that you want the building to have.
Yeah, so I guess like mass customization is kind of the vision where to go, but this really depends on the number of projects that hopefully will increase over the years. I think for now, I guess it's the formwork is the limiting factor. You just don't want to build like too many different pieces of formwork, otherwise it's not going to be economically viable and efficient. So that's kind of, you have to kind of strike a balance between your freedom of your footprint and of what makes sense in regards to manufacturing, I guess.
Yeah, I mean, at the moment we are working on a project in Berlin that was not mentioned here. It's a different one from the one that you have seen at the slides. And this is a building where we have really unusual shapes. I mean, there's overlays of some of the massing of the building, and you have a lot of different components, but in the end they are still repeatable, and so there's not much to worry about when it comes to irregular shape of a building. The building just have to be big enough. I mean, if you just have 3 stories of a building and you call what you would call the regular floor layout is just 1 floor, then everybody can imagine that it's not very effective. But we are talking about large volume buildings, and there's always a repetitivity if you really stick with it, and if you really want it in your design.
Do you have any other burning questions that you see are extremely relevant?
I think there's one which applies to our potential foreign clients, because there's a question regarding the sourcing of our components. So where do we get our stuff from that we build the buildings with, if we do licensing, for instance? And of course, in Europe, it's pretty easy to get all the timber stuff, the framing walls, and all the raw material, and especially the expertise. So how do we do this when we go abroad to other continents or so? So the answer is pretty simple. The system itself and the design and all the detailing is made that simple that you can also do this in other countries, because all the people that are there with some training and some help, they will be able to do this by themselves. And that's what also what the licensing is about, that we enable people in other countries to help themselves building systemized timber buildings. And the best example is Singapore, for instance, where we started to set up a field factory for the hybrid panels, and there was workers from Malaysia. They had no idea of the system before, but then after, let's say, like 3 or 4 of these panels, they got it, and they really worked very carefully and very hard, and it was just beautiful products that came out of that. And so we believe that what we do is possible in any part of the world.
So Rainer, I'm sorry to interrupt you, and there's a lot of other questions coming in right now, but I think we have to wrap it up because we're already 5 minutes over time. Thanks for helping out with this Q&A session. So what I've basically want to leave you with is that in the end of the webinar, you will get two emails, one with the recording attached. You will be asked for a survey right away after you leave the webinar, and you will get another one with the handout link. And as well, I would like to remind you to look at the upcoming webinars. You will also get an invitation for those. And with the purchase of any upcoming webinars, you will actually get access to a shared project database with photographs, drawings, specs, and details. You will get access to the CREE BIM library components and manuals, and you will be able to participate in the upcoming design competition in the end of 2018. So just a reminder on that, and thank you very much, everybody, for dialing in today. And this was our first webinar. Thanks for joining, and goodbye.